Hello guys, welcome to the channel, and today we're going to be solving this problem here. Okay, and the domain we're going to be considering is the real numbers. Okay, we're going to be solving for the real numbers. Okay, so to start, I'm going to make a substitution. Okay, I'm going to say sine x is equal to a and cosine is equal to b. So but we know that we have to respect this condition here. And so according to our substitution, we're going to have this other condition because we're replacing sine and cosine by a and b. And continuing here, we're going to square both sides of the equation, and then we're going to add side by side. We have then that this sine squared plus cosine squared, this is 1. So we have then that a squared plus b squared is equal to 1. Okay, so a to the 5 then plus b to the 5, right? We're going to have this equation here will come to this one. So but we know that we can write a to the 5 plus b to the 5 as this product here. And now I can complete this square here, this term here, and this one here. I'm going to complete this, and I'm going to say that this is then a plus b squared minus 2a squared b squared, right? This one here is equal to a to the 4 plus b to the 4. And then from here we are going to simplify these two here, and then we're going to have minus a squared b squared, and here we're going to have this one here, right? Sorry, we're gonna actually factor out these two. Let me see, this one and this one here, we're gonna factor out this here, and then we're gonna have this one here. Okay, cool. And then we have this, and we know that a squared plus b squared is equal to 1. We're gonna replace these values here, and then we're gonna have this product here. Well, there are two things we have to consider, right? Negative 1 we can write as minus 1 times minus 1 or 1 times 1. Let's have these two conditions here to see what is possible. So first equation, then we're going to have a plus b equals to 1, and the other one is equal to 1 as well. And the second one, we're going to have a plus b is equal to negative 1, and this one as well equals to negative 1. And then we're going to solve these two system of equations to find the solution for this, and then we're going to see if there are real solutions on this for a and b, right? So let's start then solving this one here. So from here we're going to have this one, right? Okay, which this is the first one, and then I just organize the terms here, right? So then, okay, cool, we have then these two equations, these two system of equations. In the first one I just factor out a b, and the second one I'm gonna keep the way it is. So I'm gonna forget about this one, and I'm just gonna focus on the second one for this moment. And then from here, solving this quadratic equation in terms of ab, we're gonna have this one here. Remember that we're solving for the real numbers, so these are imaginary solutions, so this won't be helpful for us. So but let me find the values of a and b. Okay, so this means, guys, let me just get back here. Okay, ab, we have a plus here and minus here, so we're gonna have then these two system of equations, right? This one and this one, right? And then solving this system of equations, we're gonna have this, right? Solving this one, we're gonna have a1 a2 equals to this, b1 and b2 is equal to this, and from this we're gonna have a3 and a4, and here we're gonna have b3 and b4. But remember, our a has to be in respect to this interval here, to this condition. So this are imaginary solution, so this is not helpful, so we're gonna ignore this solution. This is the reason why this system has not solution for our problem. And now we're gonna get back to the first one, the first system of equation, which is this one here. And then from here we have that ab is equal to 0 and ab here is equal to negative 1, right? So from here we're going to have two other system of equation. The first one is this one where ab is equal to 0, and the second one is this one where ab is equal to negative 1 as well. I'm going to let this one to the end, and then I'm going to solve this one here. So from here we're going to have then a1, right? When we replace when we solve this system of equation, which is just something very simple, we're going to end up with a quadratic equation here. We're going to have a1 and 2 equals to 1 plus or minus square root of 5 over 2, and b1 equals to this. So remember that we have this condition here, right? So from here then, so we already had this. Let me just put these conditions here. You see, this one here is greater than 1. This one here is smaller than 1. So I cannot have a 1 greater than 1 and b and let me see, and b1 smaller than 1, because remember that a is sine, and sine of x cannot be greater than 1. It has to be smaller than or equals to 1, right? So this won't be satisfying our solution, even though these are real numbers here. So then we have then the last one, which is this one. So from here we're gonna have a1 is equal to 1 and b1 equals to 0. Here we're gonna have a2 equals to 0 and b2 equals to 1. And then this is respecting our condition. So we'll remember that we made this substitution, right? So now we're gonna have this one here, and then when we replace a1 and b1, we're gonna have this one, and solution for this one, we're gonna have pi over 2 plus 2 and pi, and then x2 equals to 2 and pi. And then sine x equals a2 b2 here. We're gonna have then sine x equals 0 and cosine x equals 2, and then we have this one here. As you can see, these solutions, they are the same, right? Just change the numbers here. So this means that we can conclude that the only solution for our problem is this one. So we have this solution, which is where we can have x equals to pi over 2 plus 2 and pi, or x equal to 2 and pi, where n belongs to the integers. So guys, this was the solution for this problem. I hope you enjoyed the video. Please subscribe, like the video. This is very, very helpful, guys. See you next time, and send me some problem to solve in this channel. See you next video, my friends. Bye bye.